Hi all, and this is again Mrs. V. Kannaki from R.M.K College of Engineering and Technology has come to give a short introduction about the Industrial Safety Unit 2. In the Unit 2 of Industrial Safety subject deals with chemical hazards, that is chemical exposure, toxic materials, ionizing and non-ionizing radiation, industrial hygiene and industrial toxicology. So, chemical hazards. So the very first topic what we are going to deal with unit 2 is chemical hazards. So chemical hazards are the undesired effects caused with the absorption of hazardous chemicals by the human body. The hazardous chemicals alone in concentration or when mixed with other chemical substances can cause injury, disease or death. So when you see into the effect of chemical hazard, the most tragical, that is a very major industrial accident that has happened in Bhopal, that is Bhopal gas tragedy. So when you look into this tragedy is the effect of the chemical hazards, that is due to the improper maintenance of the plant, is the effect of that tragedy is felt today also in the particular area. Is here when you say about the chemical hazard is the chemical exposures. The chemical exposures indeed are a significant safety concern. Chemicals are generally reactive, that too more than others. Okay, so chemicals are reactives more than the others. They can be combined at times, creating new materials that have new properties. They may be inert or highly flammable or even sensitive to shock. They may be toxic in some degree. Often they may damage substances by corrosion, for example. But then too, chemistry can provide some protection against such problems. In general, chemicals are willing servants, but when they are not controlled, they can become terrible tyrants. Probably the most logical place to begin a discussion of chemical safety is with the process plant. So it is that the most immediate hazardous chemical exposure is apt to exist. That is Bhopal gas tragedy, for example. It is also where the chemical safety philosophy and control programs should be most readily developed and carried out. So, to a significant extent, chemical safety leadership starts with the producing companies, and in general it may be said to be found there. Those occasions where harmful excursions have occurred usually can be traced to inadequacies in safety management. So coming to the types of chemical hazards, the chemical hazards may be due to oxidizers, flammable materials, explosive materials, acute toxicity, corrosives, gases under pressure, carcinogen materials, irritant materials and environmental toxicity materials. So we'll see some example of hazardous chemicals. So usually hazardous chemicals will lead to health hazards. So some of the examples of chemicals that may cause adverse health effects upon exposure are irritants, example is ammonia, sensitizer, that is formaldehyde, target organ effects, example methanol, more toxic, example carbon monoxide, that give reproductive effects or chemodrugs, and that creates carcinogens or benzene. When you say about hazardous chemical that lead to physical hazards or the chemicals that may catch fire, explode or react in some way. For example, compressed gases, oxidizers, flammables and combustibles, reactives and corrosives. So these chemicals will lead to physical hazards. And some examples of flammables and combustibles chemicals are, so these are the substances that can catch fire and burn. So among liquid items, the flammable liquid is examples are acetone and gasoline, and combustible liquids are motor oil and mineral oil. Flammable gas are hydrogen and propane. Flammable solids are metal powders and matches, and flammable aerosol or spray paint. And how to handle the flammable and combustible materials. So the safe handling and storage. So if you look into the flammable storage cabinet here, see the best handling of the flammable combustibles, or we want to keep the container closed when it is not in use, and do not use near open flame or ignition source. And the flammable liquids are to be stored in flammable storage cabinets, and the containers, the ground and bond containers over 5 gallons. Oxidizers. So oxidizers are substances that increase the burning of fuels by increasing the oxygen. Examples are benzoyl peroxide, concentrated nitric acid, and sodium hypochlorite. How to handle this? That is the safe handling of oxidizers and storing it, or they should not be mixed with fuels, and they should be separately stored from flammables and combustibles. So usually oxidizers are very reactive. In many cases, contact with combustible material will result in fire. Reactives. So reactives are substances, or it is a compound that is capable of catching fire or exploding if subjected to certain conditions, like for example water reactives. Water reactives example sodium metal, and shock sensitive or dry picric acid, and explosives or nitroglycerin. And handling of these reactive components is just instead of using this, we can use a substitute with less hazardous materials whenever it is possible, and these components must be stored in isolation from other chemicals. Corrosives. So here corrosives again you can call as acidic or caustic. That is capable of destroying human tissue, and acids can also destroy the metal. So when you say corrosive substance as acids, as we can give some examples like sulfuric acid and hydrochloric acid, and bases examples are sodium hydroxide and ammonium hydroxide. And how to handle and storage these corrosive materials are, we want to store the acids and bases separately, and metal containers should not be used to store or dispose of acids. And when we work near the corrosive materials, we should have a high wash, shower or hose. Controlling chemical hazards in the workplace. So reduce or eliminate the use of hazardous chemicals whenever possible. Maintain adequate ventilation systems to reduce concentrations of airborne chemicals. Practicing good personal hygiene. Example, washing hands and maintaining regular workplace cleaning routines. Learn how to avoid carrying hazardous substances to home. And introduce administrative controls to minimize exposure to chemicals. Example, rotate workers to different jobs or locations. Perform maintenance work in off hours so that accidental release of toxic substances will affect fewer workers. Use personal protective equipment and devices. Maintain equipment in good order to prevent leaks and breakdowns that may release toxic substances. So next we'll see about toxic materials. The sources of toxin are environment, food, feed or water and drugs. If you say environment, yes, air pollution, poor ventilation and volatile components. Toxicity. Toxicity is the degree to which a substance can damage an organism. It can refer to the effect on a whole organism such as an animal, bacterium or plant, as well as the effect on a substructure of the organism such as a cell, that is, we call that as cytotoxicity, or an organ such as liver, that is called as hepatotoxicity. And toxicity is the capacity of a chemical compound to produce injury. Outcome, when we look into the outcomes of toxicant, death after a short period of time. So that type of toxicity is called acute toxicity. And the other outcomes are cancer and mutation in DNA, skin or eye irritation, fertility problems, carcinogenicity, mutagenicity, reproduction effects, sudden heart failure and death. So when we see about the toxicity, how poisonous are chemicals, so the dose, the effects of any toxic chemical depends on the amount of a chemical that actually enters the body. And acute toxicity is the measure of how toxic a chemical is in a single dose over a short period of time. Chronic toxicity is the measure of toxicity of exposure to a chemical over a long period of time. Chronic toxicity and acute toxicity. If you look into the difference of this, see a good example here is ammonia. So here the chemicals will only make you sick if you get an acute or high dose all at once. And some chemicals are mainly known for their chronic or long-term effect. Example is formaldehyde. And most chemicals have both acute and chronic effects. Example is carbon monoxide. Coming to radiation. Yes. So when you say about radiation is nothing but signals emitted from either the atoms, unstable nucleus or its unstable orbital area. There are two general types. One is particulate radiation, another is electromagnetic radiation. Particulate radiation. So the radiation phenomenon is one in which forms of energy affect the atomic structure of matter in various ways. When the atom is in a stable or unexcited state, the electrons move in orbits at a certain distance from the nucleus. So when the atom absorbs energy in its orbital area, the orbital distance of the electrons is increased and the atom is said to be excited or in an unstable state. The atom absorbs or emits energy in a certain amount called a quantum or a photon. during such a transition. In each atom, several transitions are possible with a fixed energy level scheme. So the nucleus also can have different energy levels. If the internal energy of nucleus is increased, it will become unstable. So radiation is emitted from either the atom's unstable nucleus or its unstable orbital area and is divided into two general types, particulate and electromagnetic. Particulate radiation, often called corpuscular radiation, and it is the motion of small particles which have mass and electric charge and which transfer energy from one point to another. These tiny portions of matter behave somewhat like a billiard ball. That is, at times they are deflected from obstacle to obstacle until they are either captured or their energy is exhausted. The more common particles are the alpha, beta, gamma, and etc. Yes. So coming to ionizing radiation. So when a radiation source is capable of stripping electrons from an atom, the process is known as ionization. So here you can classify the ionizing radiations as alpha radiation, beta radiation and gamma radiation. The last is your cosmic radiation. Alpha, beta, gamma and cosmic radiation. Alpha radiation. So in simple you can say the alpha particle is a stable, rapidly moving unit of 2 protons and 2 neutrons propelled from a disintegrating nucleus. The short range of the alpha particle reduces the danger to the body from external alpha emitters to a negligible level. And when you see about beta radiation, beta particle is a rapidly moving electron ejected from a disintegrating nucleus. The difference between the beta particle and the orbital electron is a matter of origin and energy. So when the neutron to proton ratio in the nucleus of an atom is such that the nucleus is unstable, a beta particle may be emitted. A neutron divides into a beta particle, a proton particle and a neutrino. Gamma radiation. So gamma radiation is typically the electromagnetic, having very short wavelength and very high frequency. This radiation normally occurs when a radioactive nucleus progresses toward a less excited state. For example, radioactive radium passing through many transitional intermediary stages to finally reach stable lead. Radiation protection. So radiation exposure kept below a certain level has no apparent ill effects. So always the radiation protection programs are concerned with detection and measurement, shielding and monitoring. The health physicists are responsible for those activities concerned with the radiological safety of employees, such as monitoring, hazard evaluation, supervision of waste disposal, radioactive materials in industries. So industrial research. Irradiated tools or parts to measure the wear of cutting tools, pistons, wire drawing dies. And in radiology industries, to replace x-rays in checking steel castings and welded joints. Gauging, to measure and control the thickness of steel, paint, paper, rubber and other processed products. As tracers, to follow fluid flow in process lines, transfer of printing ink. And as ionizers, to eliminate static electricity in textile and paper lines. And in polymerization, to speed or initiate chemical reactions by catalytic action. And radiation, low intensity light sources for exit signs, storage bins and traffic lane markers. So a very thank you one and all for listening to the chemical azotes and the effects of the different types of chemicals in the second unit of the industrial safety. I will join you in the next presentation with a different topic. Bye all.